So, good morning. Today we are going to discuss about the basics of algebraic expressions and identities. So, let me draw with color. Yeah, algebraic expressions. Algebraic expressions. And of course, we'll also discuss about the identities. And of course, we'll also discuss about the identities. Now, what is algebraic expression? Now, before discussing about what is an algebraic expression, we must discuss about what is a variable and what is a constant. What is a variable and what is a constant? Now, see, if you want to make it as simple as much, so we can directly say that variable is nothing but an alphabet. But wait a minute, why alphabets are considered as variables and why we are not taking any other as variables? No, as a name itself, as the name indicates itself, variable means something which varies, something which varies, and varies means changes, something which changes, something which changes. For suppose, if I can say, what is the price of the gold? What is the price of the gold? Price of the gold. And price of the gold is something that it changes continuously every day. So I cannot take the value as a fixed value. If I can take the value as some 6,000 rupees, no, it is at that particular moment. But the next day the price will be changing. So I cannot take the value as a constant value. I cannot take the value as a fixed value. So this type of quantities are known as variables. For example, in mathematical terms, the most common way of asking the question, which includes variables, is the height of A is 10 centimeter more than height of B. Height of B. Now, for this equation, if you write an expression, height of A is means we have to put equal to symbol, 10 centimeter more than height of B. Height of A is 10 centimeter more than height of B. That means if height of B is 10, then height of A will be 10 plus 10, 20. Okay, if height of B is 10, then height of A will be 10 plus 10, 20. If height of B is 20, then height of A will be 20 plus 10, that is equal to 30. That means height of A is not fixed here. Height of A depends upon height of B, and if height of B changes, height of A changes. If height of B changes, height of A changes. That means height of A depends upon height of B. So then this type of equations can be considered as an equations or expressions involving variables. Now if we don't know the value of a particular person, we can take it as x. Suppose here I don't know the value of height of B, so I can take it as some x. Then height of A will be x plus 10. For examples, if I can ask you like this, the number of marbles, with Rahul is 10 more than 10 more than number of marbles with Gautam. The number of marbles with Rahul is 10 more than number of marbles with Gautam. Here, number of marbles with Rahul is 10 more than number of marbles with Gautam. I don't know the number of marbles with Gautam, so I can take it as some x. So the number of marbles with Rahul is 10 more than the Gautam. So since I don't know the value of Gautam, I can take it as x. So Rahul will have x plus 10. Rahul will have x plus 10. So if we don't know a particular value, we can take it as some x or y or z. But the most common variable which we can take if we don't know a particular value is known as a variable, because it depends on the given condition. It is not fixed always. Okay, so like that. So these x, y, z on which we are talking are known as variables. Remember, variables can take any value depending upon the question. If I give you a number of marbles with Gautam as some 10, then Rahul will have 20. If I give you a number of marbles with Gautam as some 20, then Rahul will have 30. That means this value can be anything. That means it may vary, it may change. So it is known as variable. Okay, like that. Now what is a constant? Now constant is something whose value does not change. Constant is something whose value does not change. So I'll write here. Constant is something whose value does not change. Value is always fixed. Value is always fixed. For example, in this equation, this is known as variable and this is known as constant. So even though the value of x changes, this does not change. X can take any value, depends on the condition, but only x will change and 3 will be always fixed. It will not change. Okay, now if I give you a question like this, so 5x plus 4, and this is known as variable, whereas this is known as constant, and this 5 is coefficient of x, coefficient of x. Now see, now we'll discuss about what is a monomial, what is a binomial and trinomial, etc. So now that you got some clarity on what is a variable and what is a constant. Variable is something which changes, depends upon the condition, and constant, it is independent of the condition. No matter what the condition is, constant value is always fixed. Now what are these expressions? Now expressions are combination of these variables and constants, as simple as that. Now this is an expression because it contains both variable and constant, and this is an expression, it contains both variable and constant, and this is also an expression because it contains variables, and this is also a variable, I mean expression, it contains variables, and this is also an expression, and this is also an expression. Algebraic expression is very simple. It is an expression which contains both variables and constants. Both variables and constants. Now if you can see, observe here, if you can observe here, you will get some clarity on what we are discussing. expressions are formed from variables and constants. The expression 2y minus 5 is formed from the variable y and constants 2 and 5. The expression 4xy plus 7 is formed from variables x and y and constants 4 and 7. So like that, we can form different expressions by combining these variables and constants. Okay. Now this is also known as algebraic expression, or simply we can call it as expression. Yeah, we know what is the value of 5. 5, for example, if I can take the value of 5, if I want you to indicate how much is 5, you can simply take a number line having from 0 1 2 3 4 5 6 7 8 9 10, and you can simply mark it with the help of scale from 0 to 5. So this indicates the magnitude. This indicates the magnitude that it is as big as the number 5. Now if I want you, or if I ask you to find what is the size of x plus 5, but before that you must understand this x is a variable, right? It doesn't have any fixed value. So what I'll do is, I'll take a number line, I'll mark somewhere the position as some x, and from there I'll mark 5. So this indicates x plus 5, and whenever this changes, this entire expression will also get changes. For example, if x is as big as this, and this will become x plus 5, because 5 is always fixed, right? So like that. Okay. It is very simple to understand, and you can simply go through these lines. Consider the expression x plus 5. Let us say the variable x has a position x on the number line. X may be anywhere on the number line, but it is definite. The value of x plus 5 is given by a point P 5 units to the right of x. That means x plus 5 means first we need to plot x, and from then we have to move 5 units right side, because we are adding plus 5, right? So when we are adding something, we should move towards the right side. Okay, that's it. And we should not worry much about this, because it is not as important as problems. Okay, we can straightly go to the problems. Yeah. Now there comes some other important terms which we need to get clarity before starting the problems. So these are nothing but terms, factors, and coefficients. Now all this can be explained with the help of a simple example of algebraic expression. Let me take an expression of some x square minus 5x plus 6. Now can you guess this expression contains how many terms? Yes, this expression contains 3 terms: 1, 2, and 3. So this expression contains 3 terms. Now wait a minute, why can't this can be considered as one more term? No, this is a single term. This is a single term. Whereas this is also a single term, and this is also a single term. Now I will explain how terms are classified. Now we should only count terms when they are separated by either plus or minus symbol. You should make a note on that. Okay, yeah, we should make a note on that. Terms are nothing but quantities which are separated, which are separated by either plus or minus symbol, which are separated by either plus or minus symbol. Quantities which are separated by either plus or minus symbol. For example, if an expression is given like this, there is no plus symbol, so that means it is only having one term. And quantities having only one term can also be called as monomial. Now, what about this? Here, these two quantities are separated. These two quantities are separated by plus symbol. These two quantities are separated by plus symbol. So that means there are two different terms, first term and second term. So when there are two terms, it is known as binomial. And what about this? See, do you observe any plus or minus symbol here? No, right? That means this entire quantity is only a single term. So it's also a monomial. I told you very clearly, we should only differentiate terms. We should only count separately when there are plus or minus symbols. Otherwise, they are considered a single term. Now this is one term and this is one term, because these two quantities are separated by this symbol. So this is one term, this is one term. So there are two terms. And when there are two terms, it is known as a binomial. Like that. Here there are three terms, 1, 2 and 3. It is known as trinomial. If it is more than one, we can simply call it as a polynomial. It's also a polynomial. It is a polynomial. It is a polynomial. Or poly means many. Poly means many. If there are more than two terms, we can simply classify it as polynomial. Okay. Yeah. Okay. Now, can you tell me whether this is a polynomial, I mean, a monomial or binomial or trinomial or polynomial? This is a monomial. This is a monomial. Because it does not contain any plus or minus symbol. Here quantities are not separated by plus or minus symbol. So this is a monomial. If it would have been like this, then it is a binomial. Because here terms are separated. Here terms are separated by plus symbol. So then it is a binomial. So otherwise, this is a monomial and this is a binomial. Okay. And also in this topic only, we will discuss what is coefficient. Now, coefficient is nothing but the number which is placed in front of a variable. I'll write here. Coefficient. The number which is placed in front of a variable. For example, what is coefficient of x? in the equation 3x plus 5, the coefficient of x is number sitting in front of x, which is number 3. That's it. That is the answer. That is the answer. Now what is coefficient of x square in x square minus 5x plus 6? And the answer is 1, because coefficient is nothing but the number which is in front of that quantity. Now I asked you what is coefficient of x square in this equation. If there is no number before the quantity, by default there is 1. Okay. Now if I ask you what is coefficient of x in the same equation, if I ask you what is the coefficient of x, the answer is minus 5, like that. And what is coefficient of x cube in the same equation? I'm not giving x cube here, I'm giving the same equation. But I'm asking you what is the coefficient of x cube in this equation. Now in this equation there is no x cube term itself. If there is no term, then what would be the coefficient? Coefficient of x cube is nothing but 0, because there is no term at all. Okay, that's it. Right, you can see some examples here. You can read some examples, you can read paragraph, you can see some examples here. Here, expressions of monomial, examples of monomial means single term. This is a single term, this is a single term, and this is also a single term. Single term, single term, single term, single term. So like that. Okay, what we have discussed in the above lines, so that's what given in the paragraph. Okay, so now that you got some clarity on what is a monomial and what is a binomial, and what are terms and what are algebraic expressions and what are variables, etc., right? Now we will discuss something more than this, so that is known as degree of an equation or degree of an algebraic expression. Degree of an algebraic Suppose we have an equation like this. Say this is an algebraic expression. Okay, this is an algebraic expression in x, so it is completely the function of x, because the expression includes only variable x. Now if I ask you what is the degree of this equation, the degree is nothing but highest power of x. A degree is nothing but highest power of x in that equation. If the equation is in variable x. For suppose if the equation is in y, then we have to check highest power of y. Okay. If the equation includes both x and y, we should calculate for both x and y, and we should put the highest number. Okay. Now here the degree is 2, because here the power is 2, here the power is 1, and the highest power is 1 is degree. So as usual, the highest number of 2 and 1 is 2, so that's why degree is 2. Let us say we have an equation like this. So the power is 3, 2, 1, and here there is no x term. That means the degree power is 0 here. Now what is the degree of this equation? As usual, degree is nothing but the highest power of x in that equation. So here the highest power of x is 3. So degree would be obviously 3. For suppose we have an equation like this. Here the degree is 2. Here the degree is 2. Here also the degree is 2, because both are multiplied. 1, 1. We know that a power m into a power n is equal to a power m plus n. When two variables are multiplied, their power should be added. So here also degree is 2, and here also degree is 2. Power is 2. So 2, 2, 2. The highest number is 2 itself. So degree will also be 2. I think now you got some clarity on what is a degree. Okay, degree is simply the highest power of x in that equation. If that equation is in x, if the equation is y, we should calculate the highest power of y. That's it. Now what are like terms? Now usually students make a mistake, like x plus 2, they'll write it as 3x, which is a major blunder. X plus is not 3x. We cannot add x and 2 because x is a variable and 2 is a constant. We should not add. We cannot add. We can add or subtract. We can add or subtract only like terms. We can add or subtract only the like terms. That is very important here. We can add or subtract only like terms. That's very important here. Okay. So remaining terms cannot be added or cannot be subtracted. So that we should remember. So x plus 2 should be left it as x plus 2 only. Whereas x plus 2x can become 3x. 4x plus 3x can become 7x. Or x square plus 2x square can become 3x square. Okay. So we can add only like terms but not the unlike terms. That we must remember. Okay. What about 3xy plus 2xy? It will be equal to 5xy. That we must remember. Okay. I think you got some clarity on how to add like terms, right? We can only add like terms. Unlike terms we cannot add. We should leave it like that only. Now finally, we should know how to multiply a polynomial with a polynomial. First, before that, so I will explain how to multiply a number with a binomial. For suppose we have a number 2 and we have a binomial x plus 3. Now how to multiply a number 2 with this binomial? It is very simple. When we have a binomial and a number, we should multiply this number with each and every term in that binomial. So 2 into x will be 2x plus 2 into 3 will be 6. So answer is 2x plus 6. Similarly, if we have expression like this, x plus 3 into x plus 2, we should take this number and we should multiply with each and every number in other expression. So x into x will be x square, x into 2 will be 2x, and with 3 we should multiply again. 3 into x would be 3x, and 3 into 2 would be 6. So it would be x square plus 5x plus 6. So there are 3 terms in this expression. So this is how we should multiply a binomial with a binomial. So let me explain you one more example. Let us say we have x minus 5 times x plus 4. As usual, we should take the first number in this expression and we should multiply with each and every term in the other expression. So x into x would become x square, x into plus 4 will become plus 4x, then minus 5 into x, this minus is also important, minus 5 into x will become minus 5x, and minus 5 into 4 will become minus 20, which would again become x square. 4x minus 5x will become minus x and minus 20. So if you have any doubts, you can see this example here. Here it is given as 3a plus 4b, 3a plus 4b into 2a plus 3b. So first we need to multiply 3a and 2a will be 6a square, and again with 3a we should multiply one more term. 3a into 3b will be 9ab, and with 3 we completed everything. Now we have to move with 4. 4b into 2a will be 8ab, and 4b into 3b will be 12b square. So 6a square plus 17ab plus 12b square, and that's how we'll calculate. Okay, clear? Right. So we got few more examples of this binomial with binomial multiplications. You can do it as a homework and you can check the answers here. And we have some standard identities which we must remember it for lifetime. So these are known as algebraic identities, and we must remember it for lifetime. That's very important, I mean it. So which are nothing but a plus b whole square. Don't worry, we have a proof and we already done it. So a plus b whole square can be proved with the help of a square. Suppose we have a square here. Let us say we have divided into some 4 different parts of side A and side B, and this will also be A. So this will be B, this will be A, and this will be B, B, and B here. So this 1, 2, 3, 4. Now this entire side will be A plus B, and this entire side will be A plus B, and this will be A plus B, and this will also be A plus B. And now this is a square of side A plus B, and what is the area of square is nothing but side into side, so which is given by A plus B into A plus B, and this area should be equal to sum of these 4 areas, right? So this is a square, and square area is side into side, so A into A we got A square, and this is a rectangle. Rectangle area is length into breadth, so B into A, which is AB, and this is also a rectangle of side B and A, which is also AB, and this is a square of area B into B, which is B square. So A square plus B square plus AB plus AB, which is equal to 2AB. But don't need to remember all these things. You can simply remember this expansion formula a plus b whole square is equal to a square plus b square plus 2ab. Like that, we got some few identities which you must remember for lifetime. A plus b whole square is equal to a square plus 2ab plus b square, and a minus b whole square, which is very important to remember, a square minus 2ab plus b square. Only for this 2ab term we have minus symbol, and a square minus b square is equal to a plus b times a minus b. That's very important. And similarly, we have some other formulas like a plus b whole cube also. A cube plus 3a square b plus 3ab square plus b cube, and a minus b whole cube will be a cube minus 3a square b plus 3ab square minus b cube, and we have one more formula which is very important, which is nothing but a plus b plus c whole square, which will be a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Now if you observe closely, when we are doing squaring, the number of terms are 3, 1, 2 and 3. So here also we are squaring, the number of terms are 3. But when we are cubing an equation, the number of terms are 4. That means the number of terms will be 1 more than the power. If power is 3, number of terms is 4. If power is 4, number of terms is 5. And power is 5, number of terms is 6. But wait a minute, this holds good for binomial and not for polynomial. Okay, so for polynomial, here already we have 3 terms, and when we do squaring, the number of terms will become 6 terms. And how to expand polynomials based on this, we will discuss in the next class. So stay tuned for, and just revise this class once again by going through all these points. Here we have the algebraic identity and application. I'll just go through this example because it's very simple. I don't want to make a waste of your time. So 2x plus 3y whole square can be calculated with the help of a plus b whole square. And a plus b whole square is given by a square plus 2ab plus b square. See, how to know which formula should be applied? Now whenever you see the expression like this, 2x plus 3y whole square, in whole square we got only 2 identities. One is a plus b whole square and one is a minus b whole square. And since it is having a plus symbol, we must remember this formula a plus b whole square, which is given by a square plus 2ab plus b square. Now in place of a we got 2x, and in place of b we got 3y. Now just expand according to the formula. 2x whole square, because in place of a we got 2x, and in place of b we got 3y. Just put 2x and 3y in place of a and b, that's enough. So 2x whole square is 4x square. 2 into 2 into 3 is 12xy. And 3y whole square is 9y square. That's it. Okay. So you can expand all these polynomials with the help of this algebraic identity. So that's why we must remember all these things until our life, because it will be useful everywhere at each and every point of life. So just go through these points once. You can pause the video and go through these points once. How expressions are formed with the help of variables, constants, terms are added to form expressions, and terms themselves are formed as a product of factors, like terms, and monomial multiplied with the monomial gives a monomial identity, the famous identities. Of course, this I mean, it's not much required to remember. You can simply do multiplication. Okay, so you can go through this. So after pausing the audio, after pausing the video, so go back to the video from the first minute and just revise what is a variable, what is a term, what is a constant, how are algebraic expressions formed. So then you will have much clarity on what you are learning. Okay, thank you, all the best.